gas bladder there. It's actually connected in the pneumatic duct to essentially the mouth of the fish, allowing the fish to gulp air.
Oh, I can see.
Sticks its head above water and actually gulps air.
Okay, I can see
Right.
because I can see the difference in the stomach, where the stomach is located.
Well, I mean, that's essentially they've moved the stomach out of the way so that you can see.
Oh, okay. Right.
But the difference is, this connection via the pneumatic duct to the buccal cavity, whereas in the Phyzoclustus fish, this gas bladder just sits off by itself. And it's all covered, it's all vascularized, so it's covered in blood vessels. Right? And we talked about, so here's your swim bladder here, and on the surface of the bladder, all these gas glands, where CO2, oxygen, other gases get diffused out of the blood, right? So the gas gland secretes lactic acid, makes hemoglobin drop oxygen. So the oxygen is actually diffused in the bloodstream, and then it goes from higher pressure in the bloodstream to lower pressure in the swim bladder to push gas into the swim bladder if the fish needs more buoyancy. Right? If the fish needs less buoyancy, essentially the reverse happens. The gas gland stops producing lactic acid, and eventually the gas will diffuse back with the pressure gradient back into the bloodstream. Yeah.
So in the case of sharks, because sharks don't have swim bladders.
They do not.
So when you think of a great white shark, when it's swimming from the deep and then going up, it wouldn't, if they had a swim bladder, that swim bladder would explode or something.
That would soften the shark, yeah. I mean, it probably would explode, but it wouldn't be able to regulate it fast enough to keep it at a fairly small size, right? So remember we talked about the buoyancy
It'll make it move
mechanisms for
slower.
sharks, right? They have these big livers that are really oil rich. So there used to be big shark fisheries for shark liver oil.